All right, so 1/6 is called inverse functions, okay? One of these are still functions, so they still take on all the characteristics of a function. They would still pass your vertical line test, all that stuff. But now, if it is a function, we're going to start to see if we can find its inverse, okay? If g is the inverse function of f, then if I find f of g of x, the result will be just x by itself, and the result of g of f of x will just be the result of x by itself. So this is the same as saying f of g of x should equal x, and g of f of x should equal x. So we will use this 1 to prove that two things are inverses of each other. 2, once I ask you to find the inverses, you can always use this to check your answer. The way we'll show the name of an inverse is this little f negative 1 of x. So if my original function is f of x, then its inverse will be called f negative 1 of x. And if you were to see f negative 1 of x, you would know that that means that is the inverse to f of x. So that's the notation for it. All right, so the first example says use the inverse function property to show that f and g are inverses of each other. The inverse property is what we just said. F of g of x would give you x. G of f of x would give you x. So I'm going to test it both ways in order to prove it. I'm going to do f of g of x, and then I'm going to do g of f of x. So for f of g of x, the g gets plugged in to the x on the f of x. So I'd get x plus 6 minus 6. The positive and negative 6 cancels out. And I get x by itself, which is what you should get. If you don't, you did something wrong if they are inverses. And then g of f of x says take f of x and plug it into the x of the g. X minus 6 plus 6. And these cancel. And again, you get just x. So when the instructions say show or prove or verify that these are inverses of each other, the work is basically your answer. You'd have to have the work of both f of g of x and g of f of x. If it had said are f and g of x inverses of each other and you don't get x for either of those, then the answer is no. If you get x for both, it's yes, but if you get x for either, it's no. Yeah? For the first one? Yeah. So f of g of x says take g of x, right? And plug it into the f of x. So this is my g of x. I took it and I plugged it into the x of your f of x. It replaces the x. Okay, now we're going to do the same thing for b. I know this spacing is a little weird, but this is g of x, x plus 3. So obviously that's just separated out. We're going to talk about this restriction later, so don't worry about it for right now. We'll talk about that later. What we're going to do first is find f of g of x, and then we're going to find g of f of x. So f of g, and then they're separated here, the g is going to get plugged into the x of your f. So I'd get the square root of x plus 3 squared minus 3. What is the square of the square root of x plus 3? X plus 3. And then I get x plus 3 minus 3, which is just x. Again, that's the answer I should get. And then we reverse it. G of f of x. And now the f of x comes in under the square root in place of that x. So I get the square root of x squared plus minus 3 plus 3. The plus 3 minus 3 cancel. And I get the square root of x squared. And the square root of x squared is actually the absolute value of x, which is where that restriction comes into play. Okay, but again, we'll come back to that in a little bit. What we want to keep is just positive x. And again, when we talk about how to test for inverses, we'll come back to this slide to talk about those restrictions. Questions so far? Again, so if it says show, verify, all those things, then you're doing f of g and g of f, and you're showing that they both result in an x. Okay, now if it said find the inverse, here's your step-by-step process. Step one is it's going to start in function notation. So it's going to have f of x or g of x or whatever as your initial one. We start by replacing that with y, because those are the same things. Then we switch the x and y. Every x becomes a y, every y becomes an x. Then we're going to solve for the new y, which will no longer be isolated. We'll have to manipulate our equation so that the y is by itself. And then we reverse it the last step. We replace y with f negative 1 of x, which tells it, or tells us that this is now the inverse. All right, so let's start. Example 2, they both said the same thing, but find the inverse of f. Let's start with A. Step 1 was what? Make f of x, y. Step 2, switch the x and the y. Step 3, solve for my new y. And this one could have multiple steps, but the idea here is to isolate the y. So I can subtract the 7 from both sides. I get x minus 7 equals negative 3y. And then I still need that y by itself, so I'm going to divide both sides by negative 3. And I get y equals x minus 7 over negative 3. And our last step, you have to change the y back to the f negative 1 of x. Because we changed this equation. If you leave it as y, it's wrong. It is not anymore the same equation. It is its inverse. So you have to change it. That's one of those things where if you leave it, you will get docked points. So you have to make sure to change it. Now, if this was multiple choice or standardized, you might also see this as negative 1/3 times x minus 7. Those are the same things, right? They just pulled the fraction out. Instead of dividing by a negative 3, we multiplied by a negative 1/3. Those are the same things. Both would earn you full credit, but if it was multiple choice, you're only going to see one or the other. You got to make sure that you understand that those are both the same thing. Questions so far? All right, now we go to B. Step 1 is replace f of x with y. Step 2, switch the x and the y. Now I've got to isolate that y. What's one thing I could do? Multiply by the denominator, so I'm going to multiply both sides by y plus 2. And then I get y plus 2 times x. And I have two choices. One is distribute the x. And then I have to isolate my y. The other is divide both sides by x. So I'm going to show you both ways, okay? One way, distribute the x. Move the 2x to the other side. Divide by x at the end. And then change to f negative 1 of x. Totally an acceptable answer. The other way is to divide both sides by x. And then subtract the 2. And then replace with f negative 1 of x. Because these are the same, one is just simplified further, okay? But those are the same things. Both those answers will work. Which on open-ended means you can put either one, but obviously on short answer, multiple choice, you'd have to know that one is going to be there and one will not. The process is fine in either direction, but you'd have to know how to simplify it. Good still? Questions? Still copying down? All right. Now we're going to talk about the graphs of an inverse, okay? So if I start with an initial graph, then I can graph the inverse by literally taking all my x and y points and switching them. So if on my initial graph I had the coordinate points 1, 2, 3, 4, 5, 6, then on the inverse of that graph, it's going to be 2, 1, 4, 3, 6, 5. I would switch. Think about what we did with the equations, right? We switched the x and the y. So on our coordinate points, we would do the same. Switch the x and the y. Okay. If we are, kind of like what we did with the vertical line test, if we are asking if something is one-to-one, it means it is invertible. So if something is one-to-one, it means you can find its inverse. And those two questions will literally be asked interchangeably. Is it one-to-one or does it have an inverse? They mean the same thing. If it's not one-to-one, it doesn't have an inverse. So when we said to check to see if something was was a function, we said the x could not repeat with a different y. It is the reverse here. A y cannot repeat with a different x. So if you want to put that in those words, because it means the same thing, but it's worded different, y cannot repeat with a different x. Which means in order for it to be a function that is also one-to-one, the x can't repeat with a different y, and the y can't repeat with a different x, meaning it has to literally be one-to-one. For every one x, there can only be one y, and for every one y, there can only be one x. Visually, we would use the horizontal line test. So to determine if it's a function, we use the vertical line test. To determine if it's one-to-one, which means it has an inverse, we use the horizontal line test. So for example, a parabola, is that a function? Yes, it would pass my vertical line test. Is it one-to-one? No, it would fail my horizontal line test, right? The horizontal line is going to hit it more than 1 point. So it is a function, but not one-to-one, which means it doesn't have an inverse. How about a cubic function? Is it a function? Does it pass the vertical line test? Yes. Is it one-to-one? Yes. This would be both a function and one-to-one, which means it's a function that can have an inverse. Still with me? Yeah? All right, so example 3 says determine if the graph is a function, and if it is, determine if it's one-to-one. If it's one-to-one, graph the inverse. So let's start with the first one. A, is it a function? No, fails my vertical line test. It is not a function. I'm done. These are the easy ones. Not a function. Go to B. Is it a function? Yes, it's going to pass my vertical line test. Function. Is it one-to-one? Nope, fails my horizontal. And C, is it a function? Yes. Is it one-to-one? Yes. So now we want to find the inverse. If I gave you points, what would you do with it? Switch your x and y. So this does not have tick marks. You can just draw them on because it doesn't matter as long as you're consistent. Then those points will be okay when we flip it. So if I just took those 2 points, this point would be -2, 0. And this point would be 0, 3. To find its inverse, we're going to flip it. So it would be 0, -2, and 3, 0. So I'd shift down 2. That's 1 point. 1, 2, 3. That's your other point. Oops. And there's my inverse. Questions on that one? Okay, example 4, determine if the function has an inverse. So these are really just on the left-hand side, it's just your x and y coordinates in domain and range form, right? And then on the right-hand side gives you your x and y. So, here's what I found. Why? She's so helpful today. Okay, so my 1 hour goes with 80. So it's like 180. My 2 hours go with 80. That's 280. And my 3 hours goes with 100. So in order for it to be a function, each x had to go, the y couldn't repeat with a different, no, the x couldn't repeat with a different y, sorry. And in order for it to be invertible, it has to be the other way around. So the x can't repeat with a different y, and the y can't repeat with a different x. Is this a function that has an inverse? No. Go to B. Look at your x values first. Do your x values repeat? Yes, with a different y? Yep, so no, it also does not have an inverse. I should have said determine if it's a function and has an inverse, because those are two parts. All right, the last thing is finding if it's one-to-one from an equation. So think we flipped everything involving the x and y with functions. In a function, we say that the y can't be raised to an even power or the y be an absolute value. Now we're saying the x can't be raised to an even power or be inside absolute value. What kind of graph is it if the x is raised to an even power? Parabola. It's going to fail your horizontal line test, right? And what kind of graph is it if it's in absolute value? A V, and that's going to fail your horizontal line test. So they both would not be one-to-one, which means they don't have an inverse. All right, simple yes, no. Determine if the function has an inverse. Does A have an inverse? Yes, right? Yes. Because x is not raised to an even power in absolute value, right? How about B? No. How about C? Yes. It's an odd power. That's fine. How about D? No. Easy stuff, right? We just got to keep it straight in our heads, which is what are we looking at? Okay, so I went back to that first example, right? Because now we're going to talk about why these restrictions are important. There should be separation there. Okay, first of all, look at B. It says f of x equals x squared minus 3. What would this graph be? Parabola shifted down 1. Would this have an inverse? No, it would not be able to have an inverse, which is why they do this. If it says x is greater than 0, what does that do to my graph? It only keeps where it's greater than or equal to 0, right? So it's like a piecewise function. It's saying just this part of your graph is what we're focusing on. Would that pass your horizontal line test? Yes, so that becomes invertible, okay? And then on the square root, what does this graph look like? Square root of x plus 3. It's the little arc, right? The arc, what's the transformation on it? Left 3. It would look like this, right? Would that pass your horizontal line test? Yes, so that's fine. That wouldn't have a problem. But if I didn't say greater than or equal to -3, why is that there? What happens if you go less than -3? It's an imaginary number. So that's just a domain restriction. You never have to come up with these things. Like, you don't have to come up with the restrictions. Just understand why they're there. It actually has no impact on the process of finding your inverse, but it does explain why you're able to find the inverse even if it initially would not. Does that make sense? Yeah, okay. All right, homework is web assign.